Hey, welcome everybody to another weekly recap of what we did in seventh grade math. This week we continued on with looking at more real world issues that deal with percents. So far we've looked at discounts, we've looked at commission, we've looked at interest, and this week we also spent some time looking at taxes, particularly sales tax and income tax. But we did it in a little bit different way. We started off this week looking at a situation where we looked at three states: California, Texas, and Maine. And we looked at the sales tax rates in each of these states. But as you can see, they didn't just simply tell you what the sales tax rate was. We had to use our prior knowledge on COP, that constant of proportionality, which came back up again, that y over x, and we had to integrate all that prior knowledge with what we were doing presently. So, for example, in California, it tells us a list price. So an item in California that has a list price of $12, you are going to pay a total of $12.99, including tax. So students now had to take this table and we had to figure out, okay, what is the sales tax rate in California? So one method that students chose to use was a proportion. Again, a method that we've been working on. So if we look at this, it goes from $12 to $12.99, we can see that they obviously paid 99 cents in sales tax. And if you remember that part to whole concept that we've been working on, this would be my part. And my whole, or my original price, would be this $12. And so now I'm looking for that sales tax rate, or that percent, which is always over 100, which gives me this proportion. And again, students are able to solve this to get their final sales tax rate. Another option for this would have been an equation. Again, that's what we focused on last week. So now we have two tools, we call them, to solve these problems. We have a proportion and we have an equation. And I encourage students to use the model that best fits that situation. So an equation would have been another option for this. So in this case, I would have used, again, that percent of the whole is the part, just like we talked about last week. So my percent, remember, I don't know. So I'm going to leave that as a variable, X percent. Of, again, means times. My whole, or my original price, was $12. Is means equals. And my part is that sales tax that I'm paying, that part of the price, 99 cents. And again, I can go through and I can solve this to get my sales tax rate. So that was the first problem, which many students did very well on. They were able to figure that out. The next one was a little bit different now. Next one, they give me an equation. And again, instinctively, a lot of students looked at this and said, oh, so the sales tax rate is 1.0625%. Well, no, it is not. That would be awesome if we had a sales tax of that, but no, that is not accurate. And so then some students decided, well, this is a decimal. I'm just going to move it into make it a percent. And so the sales tax is 106.25%. But obviously we used our common sense and that doesn't make sense. So now we had to go back in time to this equation, y equals k times x. And we had to remember what that k was. That k represented our COP, our constant of proportionality, which we defined as y over x. So you can see here, it tells us x is the list price and y is the price including sales tax. So if I look at this, my y over x is going to be equal to my COP. So my list price and my sale and my price with the sales tax. Now, I didn't have any numbers like over here, this table to go off of. But if I were to use this table as just an example, I would have, here is 99 cents. There is my, sorry, not 99 cents. My list price would be $12. And my price including tax, remember, is $12.99. So if I put that in my format of y over x, I would have $12.99 over 12. And this is, again, kind of confusing because if we have that part to whole, a lot of students were still used to that part being smaller than my whole. Well, in the real world, that's not always the case. In this case, this is kind of like we gave the analogy of this is kind of like a markup. So we started here and then we marked it up another 99 cents. So that means that if I were to write a proportion for this, So if I were to bring in my proportion, this number on top should be bigger than this number, so it's going to be over 100%. So the question is, why would it be over 100%? Well, we talked about the reason why it's over 100% is because that 100%, remember, represents my original price, my whole. So that's my list price, which in this case would be the $12 plus whatever's additional to that, whatever's over 100%, that is my sales tax. And in this case, back over here, if I use this analogy, that would be my 99 cents. So 12 plus that 99 cents gives me my sales tax. And over here, that would be whatever my sales tax percent would be. So if I come back over here now to put all the pieces together here, I look at that 1.0625. So the first part I'm looking at is this 1. What is that 1? Well, that's my whole. That's 100%. That guy represents my list price. Plus, again, now the rest of this, I have that 0.0625. Well, that 0.0625, that's a decimal. If I convert that to a percent by moving that decimal over 2 places or multiplying by 100, I get 6.25%, which is my sales tax rate. Okay, so again, I'm bringing a lot of things together on that. The COP, we got our equation. We're bringing in that idea of a whole and a part, or that 100% plus an additional. So a lot of things included in that. So that was a true test for students to come up with the sales tax from that equation. And then the last one, which students did pretty well on, was now they give us a graph. So again, notice table, equation, graph. Those 3 components, big 3 components for what we're going to spend a lot of time on this year, and we've already this year spent a lot of time on that. So we get to the third one, the graph, and students remembered, well, before we were able to graph, we need coordinates. And typically the coordinates came from a table. So really, all we're doing is we're picking a point. So for example, let's pick this point right here and look at those coordinates. So if I were to put those into a table, an XY table, it would be 100 and 105. And it tells me on my X that this is my list price, and it tells me on my Y that this is the price with the sales tax. So again, you can see that it went from $100 to 105, which meant that I'm paying $5 in sales tax. So that's my part. If I'm going to use a proportion, which I'm going to set up right now, my original price was 100. And before students moved on to the rest of this, they immediately noted, oh my gosh, look at that. They were very kind to us, and they already put it over 100. So I already can see this is 5 per 100, or simply 5%, which is my sales tax. So from there, students then were able to solve a bunch of problems dealing with sales tax and some other questions that they asked us. So this was the only thing that was really different this week. We did go back and we looked at some problems with commission, and we ended the week actually looking at depreciation. Students learned a little bit about why buying a new vehicle is not always the best investment and how much that depreciates in value. And again, we looked at that as that's kind of like a markdown. So students have already worked with those problems, and they quickly realized that basically everything we have been doing this entire percent unit was all based on that concept of a percent of a number. And we could use a proportion, and we could use an equation to solve those. So we're going to end this unit on Monday with the test. Tuesday, we are going to start a project where we're going to integrate all of these new concepts that we've been learning with percents into their own personal lives and where their lives may be headed down the road in a certain school or career. And we're gonna, like I said, integrate these concepts into that project. So you'll learn more about that. In fact, in the email that you got this video, there is going to be a link that you will see that'll give you some more insight and details on that project. So I hope everybody has a great Thanksgiving and safe hunting season. And we will see you next week. Bye.